So today we're gonna look at a couple of MC questions from genetics, which are 10 to 13. Now let's look at the directions first. It says question 10 to 13 refer to the following family pedigree, which shows the inheritance patterns of the ability to roll the tongue. Tongue rolling is a dominant character. And so here's the pedigree with the key. And in 10 it asks which of the following is true for F, which is this one. And obviously she's a female, not female roller, and so this tells us that her phenotype is a roller. And let's look at her phenotype. Since she's a roller, this means that she must possess an allele for at least one allele for rolling, which is the dominant allele. And since that she gives birth to a male non-roller when she crosses with a male non-roller, this tells us that this male non-roller must have received at least one recessive allele from her, because he would have received the other recessive allele from his father, who happens to be a non-roller, which is homozygote recessive, meaning that he has both of the recessive alleles. And so this tells us that F has one dominant allele and one recessive allele, making her heterozygous. So this gives us the answer that is B for 10. And 11, it asks us which of the following statement is true, and the genotype of these diseases are similar to what and different or similar to what. And so basically it's asking us what are the genotype of P, F, and W and their similarity or difference. And F, as we have just proved it, she's heterozygous dominant. And so let's go to B, which is here, and she's a female roller, meaning that she must possess at least one dominant allele for tongue rolling. And since she has a father who is a non-roller, meaning that this male non-roller must have passed one recessive allele of non-rolling to this daughter, meaning that this daughter has both an dominant allele for rolling and recessive allele for non-rolling. So this makes P heterozygous dominant. And if we look at W, which is here, it says that she is also a female roller who is a daughter of a female non-roller and a male roller. And since this female non-roller is homozygous recessive, she must have passed one recessive allele to this female roller W. And so, but when this W is a female roller, this means that she has a dominant allele for rolling, which in this case must have been from this S, who happens to be a male roller. And so this tells us that she has both an dominant and recessive allele, and so this tells us that W is heterozygous. And so this tells us that P, F, and W all are being heterozygous, meaning that they are all similar in terms of genotype. And if we look at the 12, it says if R and S can never have a non-roller child, their genotype should be these. And now in the cross between R and S, it says can never have a non-roller child. It means that none of these childs will ever be a non-roller. And so this tells us that none of these child will never be homozygous recessive. And so this tells us that these childs will never receive two recessive alleles when they are given the alleles from these parents. And this means that these two R and S cannot pass recessive alleles to their offsprings together. And so this means that S can never pass any recessive alleles to his offsprings. And since he's a roller, this tells us that he must have possessed some dominant alleles, and given that he cannot pass any recessive alleles to his offspring, this means that he doesn't have any dominant alleles, making that both of his alleles are dominant, and so S is homozygous. And obviously R is a non-roller. The only case that a non-rolling character can be saw is that when R possesses two recessive alleles, making her homozygous recessive. And so R and S must both be homozygous, making the answer to 12A. And now if we look at 13, it says if the genotype of S is similar to that of Q, the chance of R and S having a non-roller chances is either one of these. And let's look at the cross between R and S, which is here. And since we don't know the real genotype of S, the question gave us a condition that is similar to Q, which is here. And so Q is a roller, meaning that he must have at least one dominant allele for rolling. And since that this father is since that Q's father is a non-roller, and so this father must have passed one recessive allele to Q. So this means that Q has both of the dominant and recessive alleles, making him heterozygous. And so since S have a genotype similar to Q, so S must be heterozygous as well. And when R is a non-roller, this makes us homozygous recessive, as we proved it before. And so when these two cross, the genotype of S is heterozygous, and for R is homozygous recessive. So these are the gametes produced. And when they cross, this produces two types of genotypes found in the offsprings, which are tongue rolling and non-tongue rollers in the ratio of 1:1. And so they both occupy around 50% of each other, and so the chances of having this non-roller homozygous recessive must be 50%, which gives us the answer of C to 13.